Hello guys, I am Vignesh. In this video, we'll discuss about the topic the language of PDA and from the subject theory of computation. The language of pushdown automata. This presentation will explore the fascinating world of pushdown automata, their role in informal language theory and their application in real-world scenarios. The fundamental concepts explores the different types of pushdown automata and understand the relationship with context-free grammars. First, introduction to pushdown automata. What are they? Pushdown automata (PDA) are a type of abstract machine used to recognize context-free languages. They are similar to finite automata but with an additional component, a stack, which is a lost in first out in a data structure used for storing information. The key components. A PDA consists of a finite control unit, a read-only input tape, a stack, and a set of translation rules. The control unit reads input symbol, changes the states, and manipulates the stack based on the rules. The formal definition of pushdown automata. PDA is PDA is a formally defined as a tuple. First, Q is a set of states, and sigma is the input alphabet for the stack alphabet, and transition function. Q naught is the initial state, Z naught is the initial stack symbol, F is a set of finite states. A transition function. A transition function maps a state and input symbol or empty and a stack symbol to a new state and also a stack operations. This function defines how the PDA transition between states and manipulates the stack. Acceptance condition for pushdown automata. Empty stack acceptance. A PDA accepts a string if it reaches the final state with an empty stack. This is a common acceptance condition for a PDA. And final state acceptance. A PDA accepts a string if it reaches a final state regardless of the stack contains. This condition is often used in case where the final stack configuration is not relevant. So relationship between pushdown automata and context-free grammar. First, equivalence. Second, context-free language. And third, parsing algorithm. In context-free language, pushdown automata are closely related to context-free grammar, known as S2 CFG. A language recognized by a PDA is exactly the same as the language generated by the CFG. This equivalence is fundamental to the theory of formal language. Parsing algorithm. This relationship is essential for parsing algorithm used in compilers and interpreter. This algorithm used in the equivalence between PDA and CFG to convert a string into their corresponding parse trees. Deterministic pushdown automata. So deterministic behavior. Deterministic pushdown automata or DPDA are special case for PDAs where the transition function is a deterministic. This means that for any given state input symbol and stack symbol there is exactly one possible transition. Subset of context-free language. DPDS or deterministic pushdown recognize a subset of context-free language known as a deterministic context-free language, while DPDS are less powerful than general PDS. They are still important in a practice as they can be implemented more efficiently. Non-deterministic pushdown automata, multiple transaction and recognition power. In multiple transaction, in non-deterministic pushdown automata known as NPDA, the transition function is non-deterministic. This means that for a given state, input symbol and stack symbol, there can be a multiple possible transitions. Second, NPDA are more powerful than DPDAs as they can recognize all context-free language. The non-deterministic the non-deterministic allows them to explore multiple possible paths through the state space, making them capable of recognizing a broader class of languages. So, closure properties of pushdown automata languages. These are the examples. Applications of pushdown automata. In applications of pushdown automata, first, compilers and interpreters. PDA are essential for the design and implementation of compilers and interpreters. They are used to parse programming language syntax, which is typically defined by the context free grammar. Data validation. PDA can be used to validate a data formats such as XML, JSON files, and HTML. They can check if the structure of a data conforms to the predefined grammar rules. Natural language processing. So PDAs have application in NLP where they are used to parse and analyze a sentence. They can help identify the grammatical structure of a sentence and extract a meaningful information. Limitations and extensions of pushdown automata. Pushdown automata are powerful tool for recognizing a context-free language, but they have limitations. They cannot recognize all type of language, such as context-sensitive language. This language require a more complex computational mechanism such as linear bounded automata to be recognized. However, PDA can be extended by adding additional features like multiple stacks or more complex transition function. These extensions allows them to recognize a wider range of languages. Thank you for watching my video.